Imagine having a device that could tell you the temperature instantly. You wouldn't need to wait for the thermometer to heat up or cool down. It would just tell you the temperature right away. These devices have already been made, and they're called thermistors. And they're using your everyday electronics, such as your phone or your computer. These devices are essential to keeping your phones functioning properly, as it keeps the phones from overheating and allows your phone to function. I'm a mechanical engineering student at RIT, and in my classes we've been discussing what a thermistor is, and for my latest project, I had to actually develop one. And through this process, I was able to understand more thoroughly how the device actually works through its circuit design, and how to actually make one through calibration and programming with the software called LabVIEW. So the way the thermistor works is a very simple circuit with three basic components. There's a voltage regulator, there's a resistor, and there's the diode. And what we're mainly concerned with is the diode, because the diode is what's going to be used to measure temperature. So the voltage regulator is just there to keep the voltage at 5 volts, which is something that the diode can handle, and the resistor is there to just keep the current at a constant rate. So what we're mainly concerned about is the voltage across the diode. And the voltage across the diode is what's going to be used to measure the temperature. So I have my device with me here. And as you can see, here's the voltage regulator, here's the resistor, and here's the diode. And the diode is connected to a long wire. That way, that you can place the diode into whatever you want to measure, and it will tell you the temperature value without having to place a whole circuit inside whatever you're measuring. So what we do is we measure the voltage across the diode, and that will give us the temperature values. So the way this works is that as the voltage goes up across the diode, the temperature goes down. And this is essential. And as you can see by this graph, as the voltage goes up, the temperature goes down, where the temperature is being represented by the blue line and the voltage is being represented by the orange line. So the voltage is going up and the temperature is going down, and that's essential to understand. And what this is called is an NTC thermistor, where the voltage goes up and the temperature goes down. A PTC thermistor would be the voltage going up and the temperature going up. But in our case, it's an NTC thermistor, where the voltage goes up and the temperature goes down. And these sources have been coming from teamwavelake.com. So now that we understand how the circuit works, we need to actually have a device working so that we can take different voltage values across the diode and convert them into temperature. And if we can do this, we can gain temperature values instantly and accurately, which is what we need. So the way we do this is through calibration. So first, we need to find out what voltage values equal what different temperature values. So I placed the diode in 6 different baths of water, ranging from temperature values of 0 degrees Celsius to 89 degrees Celsius. And I measured the voltage across the diode with a different device to see what voltage values correlated with what temperature values. And this is essential because after finding out those voltage values, those temperature values, I placed those values into Excel and I graphed those values in Excel. And the equation that I got from the graph is the conversion factor to convert any voltage value gained from this diode to any temperature value. So the more data points I had, the more accurate my device was. And so to actually have this device working properly, I needed to use a software program called LabVIEW. So in my program, which is a visual aid program, and this is a screenshot of the program, I used a DAC system, which is just a device to measure voltage across the diode and give it to the computer. So the voltage was measured across the diode and was put into the program. And the program converted that value into temperature using the equation we got from the Excel graph. Now, this temperature value is extremely accurate, and it will tell you instantly, as soon as you put the diode into a different bath of water, what the temperature is. So this is a visual of what the LabVIEW program looks like in real time, where it will tell you in real time what the temperature value is through the slider, and it will also have a waveform graph that tells you the voltage across the diode at any given point when running the program. So Thermistors are extremely important in your everyday lives. It keeps your phones working, your computers working, and any electronics that you own functioning properly. Now, I urge you all to, whenever you're using your phones or your computers, to look for these devices and recognize that these devices are there to keep your phones working properly. And without these devices, or without the ingenuity of these engineers, your phones wouldn't be able to function and your computers wouldn't be able to function. And it's remarkable that these devices can measure temperature so fast and so accurately, just by measuring the voltage. And so, as I stated in my presentation, I understood how the circuit works. I calibrated it through different, by placing the diode in different baths of water. I took those calibration data points, put them into Excel, used that graph to put that into LabVIEW. And LabVIEW was a program that I used to convert the voltage to temperature in real time. So thermistors are extremely important in your everyday lives, and your phones and computers would not be able to function without them.